Okay, so on to question 4. Xenon trioxide is reduced to xenon in acidic solution by the iodide ion. Iodide ion is oxidized to iodine, I2. What is the balanced chemical equation of the reaction? So this is an example of a redox reaction. So let's write down what they give us in the question. For our reduction reaction, we have xenon trioxide that gets reduced to xenon. And then for our oxidation reaction, we have the iodide ion, which is I-, that gets reduced to iodine. Okay, so now I have written down everything that we are given. And the first step is to make sure all the atoms are balanced. So step 1, balance atoms. So starting with the first reduction reaction, you'll notice that there are 3 oxygens in our reactant side, and there are none in the product side. So I'm also going to add that in acidic solution, we add water to add oxygens, and we add H+ to add hydrogens. Okay, so back to our reduction reaction, there are 3 oxygens in our reactant side. So I need to add 3 waters to balance out the oxygens. And after adding water, you can see that there are now 6 hydrogens on our product side. So I need to add 6H+ to our reactant side. Okay, so now those atoms are balanced. In the case of the second line, there are 2 iodines in our products, so I just need to write a coefficient of 2 in front of the iodide ion. Okay, so I'm going to rewrite this down here just so that I have more room to work with. So far we have 6 protons plus the xenon trioxide makes xenon plus 3H2O. So which brings us to step 2, which is to balance the charges. Oh, I didn't even write my oxidation reaction down. Oxidation, 2 iodide ions makes iodine. Okay, so step 2, balance the charges. And for this step, we also want to make sure that the number of electrons are the same for both the reduction and oxidation reactions. Okay, so when we balance out the charges, we kind of want the whole we want the charges on our reactant side to be the same as the charges on the product side. So to do that, we need to add electrons to the side that is more positive. So for our reduction reaction, our product side is neutral, since xenon and water are both neutral. But on our reactant side, you can see that there are 6 protons. So I need to add 6 electrons to balance out the positive proton ions. Okay, so similarly, you can see that on our oxidation side, there are 2 negatively charged iodide ions on our reactants. And for our products, there is a neutral iodine. So to balance out these charges, I need to add 2 electrons to our product side in the oxidation reaction. Okay, so like I mentioned earlier, we want to make sure the number of electrons are the same for both the reduction and oxidation reactions. So since there are only 2 electrons for our oxidation reaction, I need to multiply this whole thing by 3 in order to get the same number of electrons that I do have in my reduction side. So multiplying it by 3, we end up getting 6 iodide ions plus 6. Oh, sorry, it is going to be 3 only. Three iodines plus 6 electrons. Okay, so now the electrons are the same for both the reduction and oxidation reactions, and also all the charges are balanced as well. So step 3 is to combine the reduction and oxidation reactions to get overall redox reaction. Okay, so let's combine all of our reactants on one side. So we have 6 electrons plus 6 protons plus the xenon triiodide. And then the reactants for our oxidation is just 6 iodide ions. For all of our product side, we have xenon plus 3 waters plus 3 iodines, and then plus 6 electrons. Okay, so now we just want to cancel out the electrons from both sides since they are the same. And then let's also double check that everything is balanced. We have 6 hydrogens on both sides, 1 xenon, 3 oxygens, and 3 iodines. And for our charges, we have 6 positive charges balanced out with 6 negative charges. And for our products, everything is neutral. So the net balanced, let's just rewrite it. Okay, so now let's see what the junior tutor said. Balancing a redox reaction is different from balancing a simple chemical equation. In a redox reaction, you need to balance each half reaction, reduction, and oxidation. The number of electrons in each reaction should have the same amount, and in order to balance the charge in the product and reactant side, H plus can be added. Lastly, to balance the number of hydrogen on each side, water can be added. So as you can see for mine, we have different approaches. I like to balance my atoms first because it's easier to balance the charges after that. But to each his own, whatever you get comfortable with doing. So they showed how they added their electrons on this side. And they added 2 on this side. Yeah, again, like it makes more sense for me to balance the oxygens first. Just so that it's kind of like easier, you know how many protons you want to add. And then I like to balance the charges. But the junior tutor still ended up getting the same answer. Xenon trioxide plus 6 H plus 6 iodide ions make xenon plus 3 iodines plus 3 water. So this solution is correct.